Good evening and welcome to Lesson 10.7, Elapsed Time. Let's begin by taking a look at our essential question. How can you solve elapsed time problems by converting units of time? Well, let's begin by taking a look at our word problem. A computer company claims its laptop has a battery that lasts 4 hours. The laptop actually ran for 200 minutes before the battery ran out. Did the battery last 4 hours? Well, we've got to begin by looking at our smallest unit of measurement in this, and that's that 1 hour equals 60 minutes. So think, the minute hand moves from one number to the next in 5 minutes. So it would move from the 1 to the 2 in 5 minutes, from the 2 to the 3 in 5 minutes, from the 3 to the 4 in 5 minutes, etc., etc. So now it says to convert 200 minutes to hours and minutes. So let's begin with step 1. Convert minutes into hours and minutes. So 200 minutes equals, and remember we're going from the small unit of measurement to the big unit of measurement because minutes are smaller than hours. So when we do that, we could actually divide. So we could take 200 over here in the corner and divide it by 60. We know that it cannot go into 2. We know it cannot go into 20, so it has to go into 200. That will go 3 times 6 is 180. When we subtract that out, be a 10 and a 9. Oh, I'm sorry. That wasn't necessary, but 0 minus 0 is 0. This would be the 10, and that's still going to be a 1. 10 minus 8 is 2. So when we get that, when we divide it out, we know that 200 minutes is 3 hours and 20 minutes. So we have a total of 200 minutes. We know that going from the smallest unit of measurement to the biggest unit of measurement, we have to divide, and we have to divide by the smaller unit of measurement. So we know that they are 60 minutes and 1 hour. So the answer to that is going to be 3 hours and 20 minutes as we receive down here. So now let's take a look at step 2. It says to compare or write a greater than, less than, or equal to. So over here we have our 3 hours and 20 minutes is less than 4 hours. So since 3 hours and 20 minutes is less than 4 hours, the battery did not last as long as the computer company claims. So now let's jump down here to this try this section. Alright, so our word problem at the bottom says, Jill spent much of her summer away from home. She spent 10 days with her grandparents, 9 days with her cousins, and 22 days at camp. How many weeks and days was she away from home? So let's take a look at step 1. It says to find the total number of days away. So she had 10 days with her grandparents, 9 days with her cousins, and 22 days at camp. Altogether, that equals, if we add them up, 41 days. So that is step 1. Step 2 is to convert the days into weeks and days. So since we know that days is a smaller unit of measurement than weeks, we are going to go and divide 41 divided by the number of days in a week, which is 7, is actually 5 weeks and 6 with the days. So if we do that, 41 divided by 7, that will go in 5 times. 7 times 5 is 35. 11, 3, 11 minus 5 is 6, and that's where we get our answer of 5 with the remainder of 6. So Jill was away from home 5 weeks 106 days. Now, let's take a look at one way that we can answer that, and that is to use a number line to find elapsed time. So Monica spent 2.5 hours working on her computer. If she started working at 10:30 a.m., what time did Monica stop working? So we notice on our timeline that we start with 10:30 because that's what time it says that she started working. And since the key word started, we know we're going to move forward in time or add additional time. So it says that she worked 2.5 hours. So if we add 1 hour to 10:30, the only thing that we need to change is our hour. So 10 plus 1 is 11, and our minutes stay the same. So now if we add another hour, because it does say she worked 2, the same thing. We're going to make another jump, and that's going to, the only thing we change is our hour. 11 plus 1 is 12, and our minutes stay the same. Now, we have to jump 30 minutes because half of an hour is half of 60, and half of 60 is 30. So now we need to add 30 more minutes onto it. So if we add our half, which we now know is 30 minutes, we know that she finished working at 1 o'clock. Another way that we could have solved this problem is to use a clock to find elapsed time. So on this clock it shows her start time, and on this clock it shows her end time. So we see that she's jumping an hour each time for 2 hours, and then she jumps the last one for 30 minutes or 1/2 of an hour. So Monica stopped working at 1 o'clock p.m. So now we're going to do a couple more try this. So let's look at the ones at the bottom. Robert's soccer team needs to be off the soccer field by 12:15 p.m. Each game is at most 1 3/4 hours long. What time should the game begin to be sure that the team finishes on time? So we know that 1/4 of an hour being 60 minutes, equals 15 minutes because 1/4 of 60 is 15 minutes. So 3/4 an hour then is going to be 15 minutes plus 15 minutes plus 15 minutes equals 45 minutes. So let's look at step 1. It says to subtract the minutes first. So 45 minutes earlier. And remember, since we have the finish time and we have to find the start time, we have to go back in time. Therefore, we need to subtract. Going forward in time or starting with the start time to find the end time requires us to add. Having the end time but finding the start time requires us to go back in time and requires us to subtract. So 45 minutes earlier is going to be 11:30 a.m. So step 2 is then subtract the hour. So 1 hour and 45 minutes earlier is going to be 10:30 a.m. So the game should begin at 10:30 a.m. Now be careful of this. This is where some of you may get caught up, because if you notice, they need to be off the soccer field at 12:15 p.m. So since we crossed that noon hour at 12 o'clock, when we go back to start our start time, and we cross that 12 o'clock hour noon, we have to go from p.m. to a.m. So be very cognizant of that. Alright guys, so now I'm going to show you a couple more options or different ways of finding elapsed time. And as you can see from my chart, so go ahead and take out your math journals, push pause, copy what's down on here, and then in just a second I'm going to explain each one of these strategies to you. So the first one you see here is going to be our T-chart. The second one is going to be Zoom. The third one is going to be the number line. And the fourth one is going to be mountain, hills, and rocks. So I'm going to take a minute to break down each one of these strategies that you can use to find elapsed time. And it's going to be whichever one makes you the most comfortable and whichever one makes you most accurate. So, to use the T-chart strategy, you always want to write out the start and end times so that you can see where you get started and where you need to go. So then you create a T-chart, which is basically a T, and on the left you want to write the time, and on the right you want to write the hours and minutes between the times on the left side of the T-chart and the time on the right hand. So for instance, looking at the picture, you can see I went from 8:26 to 8:30, 8:26 to 8:30, and that is 4 minutes. So I wrote 4 minutes on the right side. I continued to do this and added up on the right side to get the total elapsed time. Alright, the next strategy that you can use is Zoom, or the Z strategy. Of course, you can do this as a Z this way, or you can do it as an N, whichever way you're most comfortable. So at the beginning of the Z, you're going to write the start time. Then you're going to work your way up to the end. First, you'll figure out how many minutes it takes to round up to the next hour. So in this example, if you start with 8:45, then they determine it takes 15 minutes to round up to 9. Then you'll write that on the line connecting it right here. Then they figure out how many hours it takes to get to the hour of the end time and write that on the slant. Then you'll determine how many minutes it takes to get from the end hour to the end time. And you'll write your end time here. So for example, I started with 8:45. It took me 15 minutes to get to the next hour. And then I added 3 hours because that was the ending hour. And that takes me to 12. And then I still had 30 minutes left to go. So I do my 30 minutes on this line and get my end time of 12:30. So I realized that from 8:45 to 12:30, it takes 3 hours and 45 minutes. All right, let's take a look at another strategy. And this is the number line, and this is the one that we just had as an example in our book. So I'm not going to spend too much time on it. You're just going to start with your start time. You're going to make your jumps down your number line, and you're just going to keep track of by adding these up to find the elapsed time. And our last strategy that I want to show you is mountain, hills, and rocks. And as you can see, this one is very, very similar to our number line strategy, except that the increments are limited to the hour, half hour at most, and 1 minute. So what I mean by this is if you have to represent 45 minutes on the number line, you cannot just simply draw a curved arrow of 45 minutes like you could on the number line. Instead, you would draw a hill of 30 minutes, and your key is down here, and then a hill of 15 minutes. The advantages of this strategy are that it's more of a visual and that the increments are broken down a bit more. So instead of having a time increment of 47 minutes, it will be broken down into 30 plus 15 plus 1 plus 1. And for me, I realized that some students seeing it this way makes it a little less intimidating. Also, the sizes of the mountains, hills, and rocks also help you visualize the differences between an hour, 30 minutes or so, and 1 minute. Again, right down here is your key. So your mountains are always going to be the hours. Your hills is going to be any increments of time between 5 minutes and 30 minutes. And then your rocks is going to be your 1 minute. So for my example up here, you can see my start time was 7:30. I used one mountain to represent 1 hour, which took me to 8:30. Then I used one hill to represent 30 minutes. And then I used a couple of rocks to represent 1 minute plus 1 minute, which gives me an end time of 9:02. So again, you can use any of these strategies that you want to, you can use the clock strategy that was also introduced in our lesson today. Whatever helps you understand and be able to calculate elapsed time. Make sure that you record all of these notes in your math journal and bring it with you to class tomorrow.